Hello everyone, September 3rd. Alright, yesterday was I was distracted, so it was very bad. So today we're gonna do a little bit better. Alright, we're gonna determine whether a list is a circle, and we've done this many times, so it shouldn't be too big a problem. I think the issue with this is still how to decide where the cycle starts. I forgot. So we use tortoise and hare, right? And then they will meet at a certain spot. And then I think is you start from the beginning and the other ones start from the meeting point, and then the next time they meet it's gonna be the, is that right? I actually, honestly, I don't remember. There's a proof, I know. I think I did the proof in the past, but I'm not 100% sure. But that should be the only way to do it. Yeah, there's a way to prove it, but I forgot how it is proven. Yeah, I don't remember, honestly. I don't remember how it's proven, but I think that's how you find it. Yeah, you want to start at the front. Actually, you should try, right? So one go two, one go one. Oh, and then they go the same speed, right? They go the same speed. But anyway, that's not what this problem is. We just solve this problem, and then we're gonna move on because I need to solve more JavaScript problems. So let's just get us over with, right? Get us over with. We have this. Oosh. All right, this node, blah 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 blah. Okay, so now we are going to do. Oh, what's this? It is exposed outside its defined visibility scope. What does this mean? I think this is what it means. It has to be a public class, right? Should be defined. No. Huh. It's public. Should be declared in a file named. If I do this, then this shows up. What's the solution for this? It's exposed outside. I have no idea. How do we solve this problem? Class is exposed outside its visibility scope. Alright, let's see. What does that mean? Java. Shouldn't include this. No, that's not what I want. We can define inside. Public and private. But that's not what I want. Okay, that's because it's private. What is this? Define visibility scope. We just define a class on the outside and you cannot use. I don't understand, man. Class is defined, exposed. Alright, here. Oh, nobody answered. Shoot. No, that's not what I want. I just want to know why. Default, private, protected, and public. What does this say? It says is exposed outside. It's defined visibility scope. I don't understand. I honestly have no idea. I think I'll let it pass for now. I'll let it pass for now. Just solve this first. I have no clue. Alright, anyway, so we have a fast and a slow. Right, so we say this node fast equals head. List node slow equals head. Right? And then we will move one forward. And if there's no cycle, then they will get out. And then if the two are the same. Oh, how do we compare they're the same? Can I just do equal equal? I think I can do equal equal. Address, right? And we say while, let's say fast, and is not equal to no, and fast dot next. Yeah, well, fast is not equal to no, and then fast dot next is not equal to no, right? Then we say if slow is equal to fast, turn true. Otherwise, slow equals slow dot next. Fast equals fast dot next dot next. All right, this. Then we'll return false. Does this make sense? Yeah, it makes sense, but I still don't understand about this thing. I call it wrong. Ooh, what the hell? Huh. How? 1, 2 minus 1. 1, 2 minus 1. That should be false. Output true. Both start with head. Oh my. Oh my. I should check at the end. That was a little oversight. But yeah, I don't understand this one. It's exposed outside is defined. Visibility scope. I think I know what it means. I think this, maybe you say, because it's only exposed here, so it shouldn't be defined outside. Maybe what if I define inside? Does this work? No, this will not work. I think in this case, yes. Like in real development, this should be in its own file. I think this is what it means. But anyway, that's not what we're gonna argue over today. We are just going to copy and paste this and call it a day. Oh. 141. Hair and tortoise. Okay, so that's that. Memorize. All right, given a function, return a memoized version of that function. A memoized version of a function is a function that will never be called twice with the same input. Instead, it will return a cached value. You can assume there are 3 possible input functions: sum, Fibonacci, and factorial. All right, sum accepts 2 and it returns. Fibonacci accepts a single integer and it returns 1 if this or this otherwise. Factorial returns 1 if, and then sum factorial Fibonacci. So I think what it means is we're gonna return a memoized version of the function, right? Return a memoized version of the function. This Fibonacci and the factorial is all the same. These two are the same. You just need to memorize one. The sum accepts 2 values and need to return this. We accept 2 values. Memorize the sum. Turn 4. So what you're saying is the key can be so the call count is 2. What can be used as key? Is tuple possible? Okay, this is a good question. JavaScript. What can be used as key? Object key. String, symbols, and numbers. All strings. You can do string. You want to do string? Oh, we can do string. We can do string. It's perfectly fine. Actually, string might be a good way to deal with this. We do string, but we get this. So how do we turn this into a map reduce? Right? We can use reduce or how do we get the argument out? Huh. That is a good question. I actually have no idea. Function. If we do function args, say console.log args, does this work? Oh shoot. Function full. Okay, 1, 2, 3. Oh, it's an array. Oh, that was interesting. It's an array. All right. So if I say, doesn't matter, right? By.join separator. Ooh, look at that. Look at that. We can use join. What if it's only one thing? Can we join this? Oh my god. I can join it. So what we're saying is, well, we have to say memo. I'll just set it to this. Okay. And then we say const key equal to args.join. Okay. And then memo key shall equal to function calling. Oh, do we do this? I'm not sure. We're calling that, and then we return memo key. Let's guess. There's a lot of guesswork here. Of course, we have to first say if key in memo, then if key not in memo. Okay, key not in memo, then we compute its value. I'll return this. Okay, does this work? Oh, I got it. I think it does. I will wait. Try it again. Oh my god, I think it does. Huh. Just not too shabby, huh? Not too shabby. I think this is 2623. All right. What are other solutions possible? Oh, JSON.stringify. Gosh, that's the better way. Oh, use apply. Yep, I forgot. You can use JSON.stringify. I think that's a better idea. JSON.stringify. I might spell it wrong. Stringify. No, you spell it right. Might be faster than join. Oh yeah. Sure thing, it's faster. Use stringify. JSON.stringify to speed things up. Okay, this one done. Move on. Snail traversal. Right, code that enhances all arrays such that you can call the snail rows count, columns count method that transforms the 1D array into a 2D array, organizing a pattern as snail traversal order. Invalid input value should output an empty array. If this is not equal to nums.length, the input is considered invalid. Snail traversal order starts at the top left cell with the first value of the current array. It then moves through the entire first column from top to bottom, followed by moving to the next column on the right and traverse the bottom to top. This pattern continues, alternating the direction until the entire current array is covered, with rows 5, columns 4. Okay, where is snail? Snail 1 row and 4 columns. So first things we shall do is to check if it's valid. Right now we just say if they say rows count times, you know what, let's do it in a editor, will be easier. If rows count times columns count is not equal to this dot length. Is that right? Because this is to access the actual thing. So if it's not equal to this, then we shall return empty, right? Let's just test this. 4. This is right. Yep, that's right. Okay, otherwise then we can do the traversal. Right, traversal. Row number, so we move that. Oh, output is gonna be this. Holy guacamole. Oh, we can do that. Let's see. How do we define? Oh, we're gonna do res equal to this. Okay, which is fine. And then I'm gonna pick this. So for I, const I equal to 0. Actually, it's, I don't remember how do we do for loop? Let I shall smaller than row count. I plus equal plus plus. Right? That I'm trying to fill out each row, and each column is gonna be interesting. Okay. Each column we can say for res dot add is add, right? I'm not sure. No, it's push. Yeah. push, right? We push 1, and then for let j equal to 0, j smaller than column count, j plus plus. All right, now we need to figure out where it's going to be. So first is this, right? And then is this is I plus 1, 2, 3, 4, I plus 4. No, 1, 2, 3, 4. Plus 1, plus 2, plus 3, plus 4, plus 5, plus 5. So it's a row, right? You have to plus that much. So it's gonna be this. I plus j times row count. So 0 plus j is also 0. So the first one is 0. Okay. Next, j becomes 1. So it's 0 plus row count. And then j becomes 2, plus 2 row counts. Actually, that's not 2 row count because here we say 1, 2, 3, 4, 5. Right? And then from here, we'll do 1, 2, 3, 4, 5, which means 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I think it's looking good, right? And then the last one will be plus 15. And then I comes here. And we still do 1, 2, 3, 4, 5. It's the same until this one. Yeah, I think. Oh, hold a second. What are we returning? Yep, that's not right because 1, 2, 3, 4, 5, and then you go this way up. Ugh. So this is plus both things, right? And this just plus right next. And this is plus both things. How about here? This to this plus 1, 2, 3 plus 1 plus 2 plus 3 plus 1, 2, 3, 4, 5, 6, 7. So initially is plus 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 9, right? Plus 9. So plus 9 plus 1. Plus 9 plus 1. And then when we go to the next one, it's plus 7 plus 3. And here should be plus 5 plus 5. Right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. And then it's 3, 7. Okay. So now what you're gonna do? That's still cool. This, and I guess it's cool. So it has to be even or odd, right? Even or odd. So when we start, it's just by itself. That's the first one. And then it's the even one. Then we need to move forward, right? We need to move forward. Hold on. I don't think we do the even odd. No. I think we'll do. Let me think. So what we can do, we'll push the first one. Okay. We push the first. We push the first element, and then the next one will be. Yeah, we need to know what it is, right? What it is at the moment. Okay, I know what it is. then I know the alternative. Okay, and then that'll be the first, and then we have the next. We'll do 1 time, 2 times, 3 times. So we're gonna say rest of push. We have the starting, this I plus, no, it's just I, right? We push the I, that's the starting point, and then we're gonna say the moves. The initial move. Let moves equals to 2 times rows count minus 1. That's the initial move, right? That's the first move. Alright, so now we're just gonna say for let j equal to 0, j smaller than columns count j plus plus. Well, j shall equal to 1 because we're doing this one. Then if j is a odd, 1, 2, 3, right? 4. If j is odd, then we say rest dot length minus 1 dot push. Push what? Push this the current and let current index equal to I. Okay, then it should be current index plus moves, right? Plus moves. Once we're done, current index equal to, we might as well just do it here. Current index plus equal to moves, and now we just do current index, right? Else then current index plus equal to 2 times row counts minus moves. We might as well do odd moves and even moves. Right? This is the first beginning. So we'll do odd moves, and this will do even moves. And since this is the same, I'll elevate it outside. Right, so for each one, we will get the current index, and then we'll put the value in. Once we've done that for everything, when we get out, this row is done. Then odd moves minus equal to 2, and even moves plus equal to 2. And we keep going, and we keep going, we keep going. Now we can do current index equal to, or we can plus equal to, right? If it is, we say odd moves, otherwise it's even moves. So this is not necessary, and then we do this, and then we do this, and then we return rest. Okay, let's give this a shot. Is this right? Well, it looks all right. 20, right? Okay, so let's say 210, 4554, 120, 21, 10, 2, 4, 5, 1, 1. Okay, that should be covering everything. Yep, looks to be accurate. It's pretty good, right? Pretty good. Yeah, it's not difficult, but requires some analysis. Snail move, odd move, even move. Push the first, then we go odd and even. Treat them differently. Treat the odd and even columns differently in terms of the number of moves, the number of forward steps. Yeah. Array fill map. Each one is a new array. So this is how you get a 2D array. Oh, it is to fill the entire thing first. And then go through each one. We can directly compute. I think it's a very different idea compared to mine. Down, up movement. Yeah, there are many different ways to do this. I think this is just, for me, the most intuitive. For me. I mean, I think this has many different ways to solve. For me, this is the most intuitive way. I do want to try one of the other methods. Which one do you want to try? Just take a look at this one. Dual iteration of rows and columns. Okay, so we go through all the rows, all the columns for each one. If the column is, oh my god, I forgot, this should be triple, right? If the column is even, which means it's go top down, right? Go top down. Just 0, 1, 2, right? So they're going top down. So if once we had here, and then we're iterating them one by one, so we top down. Okay, so we find some here, then and we're here, then it has to be that many plus the, oh, it's actually interesting. I think it's interesting. So what we're saying is new arrays dot fill, no, I'll map for each one new arrays or array dot fill wait, that doesn't seem right. Array will have to get a count. Shoot. Rows count. This is array dot column count. Fill no. Alright, so that's, we get the rest, and now we say for int I equals 0, I smaller than rows count I plus plus. Or let j equal to 0, j smaller than column count j plus plus. Right, so if j mod 2 is equal to 0, but if j mod 2 is equal to 0, we're doing this, then we say res ij shall equal to this something. What's this something? Well, whenever we have this column, so we have to go through row count times j, right? If it's 0, 1, 2, we go through 2, then plus the number of rows plus I, right? For this, yeah, we got 2 and plus 1, all right? Because this is I is 0, and we do both. Oh yeah, we do both, because rows count, this will actually give me 10. If it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's it. Else, then we're here. Then res ij go to this again, rows count times into j minus 1. No, it's still j. No, it's still j. Right? It's 2, so when we're here, we still have, no matter where you are, we do the j, right? Then need a plus, boom, 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 right? And this is I, so it shall be row count minus I, row count. Oh, here need to be careful. So this times j is already going in here, right? And if this is row is 0, 1, 2, row is 2, right? Row is 2. Row is 2. Row count is 5. So I shall do 5. 0, 1, 2, 3, 4, 5. And then we shall plus 2. Let's try this. This is 1, right? So it'll be 5 is here. 6 plus 1, 2, 3, so plus 3. Right? If it's 1, we shall plus 3. So that means row count is 5 minus 1 is 4. So we have to minus another 1. Or we can just say j equal to 0 or equal to this. So that's basically fill this up. Okay. This one right? Nope. Oh, because it should be column. Yep. I think it's correct. Actually this one's better. Straightforward. All right. I think we have time for one more. Okay, let's do one more. Flatten deeply nested array. Oh, that's a good question. Flatten deeply nested. A multi-dimensional array and a depth. Ooh. Return a flattened version of that array. A multi-dimensional array is a recursive data structure that contains integers or other multi-dimensional arrays. A flattened array is a version of that array with some or all of the subarrays removed and replaced with the actual elements in that subarray. This flattened operation should only be done if the current depth of the nesting is less than n. The depth of the elements in the first array are considered to be 0. Okay, so we want to flatten it. No, I give you an hold on, give it and then n, return a flat version of that array. Flattening should only be done. Should only be done if the current depth of the nesting is less than n. If the current nesting depth is less than n. So the first example, depth n equals 0 always result in the original arrays is because the smallest possible depth of a subarray is not less than that. The depth of 0 is less than 1. So what you're saying is you go through, right, and you have some with the depth smaller or equal to n. current depth is of nesting is less than n. That's not right. This means we want, so no, don't read this. I think it's confusing you. What n means should be the, actually that's not right. What is n? N is the depth, right? Flattening should be done if the current depth is less than. So the current depth, the current depth is 0. Depth of 0 is less. If it's an array by itself, the depth is 0. I think that's, actually I'm not sure. Yes. It's just like no nesting is 0. I think the things in the inner is 0, right? So in this one, can say this one depth is 0, right? 9, 10, 11, its depth is 0. 7, 8, and 12, the depth is 1. And 4, 5, 6, the depth is 1. And 1, 2, 3, it considers this depth is 2. Hold on, n equal to 1. The subarray starting with 4, 7, and a 13 are all flattened. This is because their depth of 0 is less than 1. However, 19 and 11 remains unflattened because its depth is 1. What? I don't understand this depth thing. Some or all of the subarrays removed and replaced with the actual values, okay? This flattening operation should only be done if the current depth. What is the definition of depth? The number of nesting, right? We can say it's the number of nesting. So the current should only be done if the current depth of nesting, it says, is less than, if the, this is where I don't understand. It says if the nesting is less than n, then we shall flatten it. It doesn't make any sense. It's usually if it's more than n, then you nest it. You flatten it. The depth of the elements in the first array are considered to be 0. Okay? If that's a 0, and should be done if the current depth of nesting is less than n. If n is 1, the current is 0. You should. I don't understand. I have no clue. Or you can think of n is the maximum nesting allowed. So nesting cannot go beyond 1, which means that doesn't make sense. This one goes way beyond. Because I can say this is 0, this is nesting is 1, this is a 1, this is a 2, right? We have 0, 1, 2. And none of them needs to be flattened because they're all larger than 0. In this case, this is 0. So supposedly this should be flattened because it's smaller than 1. And this is 1. If the current depth of nesting is less than, But this here says these nesting. I don't understand. What the hell? The depth of any subarray. Huh? Let me read again. That contains integers or other multi-dimensional arrays. And think of its nesting. Is a version of that array, a flattened array is a version of that array with some or all of the subarrays, okay, removed and then replaced with the actual elements in that subarray. That's flattened. And this operation should only be done if the current depth of nesting is less than n. I don't understand. I honestly don't understand. Current nesting. Or we can consider this array, right? This array. What's the nesting of this array? Well, this array has 1, 2, 3, and this element, and this element, right? So the outer is always 0. And in this case, it's smaller than n. So this outer needs to be flattened. And these cannot flatten, so this needs to be flattened. And this needs to be flattened as well. And this needs to be flattened. Now once we flatten, the outer array still has 0. It doesn't matter, it doesn't make any sense. It still doesn't make any sense. What the hell does it mean? If the current depth of nesting is less than n, what? I don't understand. Okay, the maximum depth of any subarray is 1. Thus all of them are flattened. Huh? The max depth of any subarray. I don't understand. I would say the outer array has a depth of 3. Because you have 1 level of nesting and you have 2 level nesting, it should be 3. I guess it's how do you count this depth? How do you count this depth? The smallest possible depth of a subarray is not less than this. Thus no subarray shall be flattened. And in this case, the smallest depth of subarray is 0. So it shall be flattened. This is a subarray, right? So flatten means some or all of the subarrays removed and replaced with actual values. Okay, make perfect sense. And it should only be done if the current depth of nesting, what's the current depth of this nesting, is less than n. The depth of the elements in the first array are considered to be 0, which means the depth of this element is 0. But because it's an element, it's not a subarray, so there's no way you can flatten that. Then this one, its depth is 1. You have to say its depth is 1, right? And its depth is 1 and is less than n? No, so this should not be. I don't know. I honestly have no idea. Like, this doesn't make any sense. What the hell? Alright, what does it mean? What does the question mean? Do you have I just want to understand. I want an explanation of the problem. Oh, these are useless. Alright, what does it mean? Flatten based on a given depth. Maintain the structure of the array up to the given depth. Maintain the structure up to the given depth. And flatten the remaining. Okay, that's another way to put it. It says we maintain the structure up to the given depth. So the given depth is 0. So we need to maintain the structure. I still don't understand. It doesn't make any sense to me. What does n mean? It basically says if your depth is more than n, then you don't flatten it. If your depth is less than n, then you flatten it. Doesn't make any sense. If you're less than n and you flatten it, could flatten make your depth lower. Then you just keep flattening it. This doesn't make any sense. I don't understand. No subarray shall be flattened. So you're saying this is 0. This depth is 0. If this depth is 0 and this depth is 1, then we say the 0 need to be flattened, but the depth 1 don't get flattened. And then in this case, this is 0, but it doesn't get flattened. This does not get flattened, and this does not, because they're all larger than. So in this case, I want 2. So this is 0, it gets flattened. This is 0, it gets flattened. This is 0, gets flattened. This is 1, gets flattened into this 0, which continues getting flattened. That might be what it is asking for. I think this is what it's asking for. So when you traverse this thing and to check if it's an instance of array, right? Do we have this? A instance of array? Yes, so we check that, and if it is, we'll call flatten on it. Right, we'll call flatten on it. With an associated yeah, so we have an n and we'll have the current level, right? Current depth. So if the current depth is larger or equal to n, then we just return by itself. If it's smaller than n, then if it's smaller than n, what do we do if it's smaller than n? Then we need to flatten it. Flatten into what? Flatten into what? Yeah, like you pass this in, right? You pass this in. The current depth is 0. And the n is 2. So you say, oopsie, this needs to be flattened. So what do you return? Or you always flatten it if it's like if it does not need to be flattened, so you will return, you will wrap another array outside of it. Otherwise, you will return this one as is. And if it's value, we just, yeah, we can do that, right? We say if it's value, if it's not an array, we just push, it's an array. And then the outside level is -1. The outside level is -1. And then this will be 0, right? And then I say if it's 0, and then we go through this one again. We go through this, but because, and so we'll return, we do not wrap another thing. Okay, yeah, we might be able to do that. It feels very weird, but I think we can do this. So here is my idea. I would say function helper, right? We'll do an array and we'll do its depth. Okay, so we say if depth is smaller than n is equal, we have to do it as well. Then we'll return Holy crap. Oh, given an array. Oh. Yeah, this is what I say. I do this, right? I wrap in another one. Otherwise, we say huh. Otherwise, we say res equal to this, right? And no. If depth is larger equal to, now we return this. Otherwise, result is this. And we say for const a of array if a is instance of array, right? Do something else, res.push a, and then we'll return res, right? We'll return res. If it's of instances array, right? Because we're flattening here because its depth is smaller than n, right? Its depth is smaller than n. So this is the flattening part, right? So for this, then we could call helper this a and depth plus 1, right? Then we'll say for const b of this res.push b. And then we'll call helper array -1. Okay, so this one help. Instance of probably, yeah. Okay, let's try all of them. I think it makes sense now. Yeah, so this is no flatten, right? This flatten by not wrapping another array outside. Okay, let's try this. Hard to understand. very difficult to understand what the question is asking about. For each nested array has its depth. If its depth is smaller and it starts with with 0. If depth is smaller than n, the array gets flattened. Otherwise, it stays as is. And we use recursion, right, to check each array, each nested array. As long as the current array's depth is larger or equal to n, all other nested arrays inside will also not be subject to flatten. Once an array needs to be flattened, another trick here is that in the recursion function, we always wrap, we return an array, right? When an array is not flattened, we wrap another array on top of it. That's the trick. Alright, now I can go see all these smart functions. Depth, ooh, define it on the outside and use closure for each vowel of array. If this, else we just push. If this and depth is smaller than n, or helper vowel depth plus 1. Huh. If it's an array and depth is smaller than this, then we call helper again. With depth plus equal 1. Okay. And depth plus equal 1. Then whatever is inside gets pushed to the result because of flattening. Okay, that makes sense. That makes sense. Whatever's inside is you just go one by one. You push, and you hit an array. Then you elevate it to the next recursion function. And if its depth, if it's a value, because you're flattening. Basically, when you elevate it, it means you're flattening this. So whatever it's in will gets pushed out to the outside as well. And whatever's inside gets up again. If it can still be flattened, then this will be flattened to this, and this will be keep flattening here, right? So for those, still flatten. If we get this, we'll get elevated again, and then this gets flattened. Oh, that's a good solution. Oh, very, very smart. Hmm. Is array. We map. Depth is larger than 0. Oh, they use a stack. I have to go back to your method. How I do flatten. I think I like the other one better, huh? Use a global res to hold the flattened array. Then during recursion, right? Then during recursion, flattening is achieved by directly pushing values to the global res, right? Yeah, imagine we can go multiple nesting array deep, but if they need to be flattened, their values all go directly to the global res, hence flattened. I'm not sure if it makes any sense, but it makes sense to me. This is fine, but that's the difference is this. We'll do a res equal to this. Right, now we don't do any of this. We'll just go through array. Right, go through array. We say if a instance of array and depth is smaller than n, right, then we need to helper this array and depth plus 1. We find a nesting array whose depth is smaller than n, then this one needs to be flattened. And now by calling this again, so we go through, actually we call it sub nest element. Yeah, call it element. More straightforward, right? Then we go through element one by one, right? And then if the depth becomes equal to, then just directly go there. So we say if this, then else, just res.push element, right? And then at the end, we'll return res, return this whole thing. So we just start calling this. Yeah, this is much simpler. I agree. It's a much simpler solution. Oh, this will be good. This will be good. Yeah. It's 95. Okay, that's enough. It's ON, right? Yeah, it's ON. That is enough JavaScript for today. All right, I'll see you guys tomorrow.